Welcome back, students. I am Bhavna. As we all know how rapidly new technologies are coming up, it has become indispensable for us to learn these future skills and stay productive. Future skills is meant for IT professionals, which will help them to upgrade their skills. With this increased use of technologies, there is a need to realign the approaches of the industry. Your journey in the field of future skills begins as a learner by exploring the platform where you can search for technologies yourself. You can follow technology to get daily learning insights. The contents are arranged to show a description of that job role through a job role card and the skills required for that job role. There is an option to personalize learning journey by choosing job role and skills that interests you. Future Skills is a simple yet powerful platform which can go a long way in future proofing your career. We have been listening about smart bulbs, smart fans, smart ACs and other smart home appliances. But do we know the technology behind it? IoT or Internet of Things is a network in which all physical objects are connected to the internet through network devices and exchange data. IoT allows objects to be controlled remotely across existing network infrastructure. The goal of IoT is to extend the internet connectivity from standard devices like computer, mobile, tablet to relatively dumb devices like a toaster. Advancements in medicine, power, gene therapies, agriculture, smart cities, and smart homes are few examples where IoT is strongly established. There are four fundamental components of IoT system. First one being sensors or devices. They are key components that help you to collect the data from the surrounding environment. All this data may have various levels of complexities. It could be a simple temperature monitoring sensor or it may be in the form of the video feed. Next up, we have connectivity. All the collected data is sent to a cloud infrastructure. The sensors should be connected to the cloud using various media of communication. These communication media include mobile or satellite networks like Bluetooth, Wi-Fi, WAN, etc. Then we have the data processing. Once the data is collected, it gets to the cloud and the software performs processing on the gathered data. This process can be just checking the temperature, reading on devices like AC or heaters. However, it can sometimes also be very complex, like identifying objects using computer vision on the video. Last but not the least, we have user interface. The information has to made available to the end user in some ways. This can achieve by triggering alarms on their phones or notifying through text or emails. Also, a user sometimes might also have an interface or app through which they can actively check in on their IoT systems. IoT has multiple advantages in form of technology optimization, reducing waste, improved customer management, and improved data collection. IoT technology is also plagued by some security and privacy issues, and currently they are complex to set up. But with passage of time, these issues have significantly reduced. Moving on to our next technology concept. Big data analytics is the process of collecting, organizing, and analyzing large sets of data to discover pattern and other useful information. Big data analytics can help organizations to better understand the information contained within the data and will also help identify the data that is most important to the business and future business decisions. The characteristics of big data can be defined using three V's: variety, velocity, and volume. While in the past, data could only be collected from the spreadsheets and databases, today the data comes in an array of forms such as emails, PDFs, photos, etc. So, based on the variety, the data can be structured, semi structured, or unstructured. Velocity refers to the speed at which it is created in real time. Consider a search engine like Google, where billions of users make billions of requests per second. So, big data also indicates huge volume of data that is being generated on a daily basis from various sources like social media platforms, business processes, machines, networks, etc. So, big data has found applications in multiple fields like governance, healthcare, banking, manufacturing, and many more. The next concept of computing we are going to talk about is cloud computing. Cloud computing does not mean that the data is stored in the clouds. It means that the data is stored in servers that are far away from where we can access the data. The name comes from the use of clouds as an abstraction for the complex infrastructure it contains in system diagrams. So, cloud computing entrusts services with the user's data, software, and computation over a network. Some essential characteristics of cloud computing are as follows: on demand self services. So, the user can access the cloud services as and when they require without the intervention of any other human. Broad network access. Cloud services can be accessed from multiple clients and platforms like computers, smartphone, tablets, etc. Resource pooling. The server resources can be pooled amongst multiple users. That is, multiple users can use the same system at any given time. Rapid elasticity. The user should have control over how much cloud resources they want to use. Consider we put up a machine with 8 GB of RAM on cloud computer. Now the user should have control to reduce the RAM to 4 GB and also increase the RAM to 16 GB wherever they require. So measured service. The user should be charged for only the services and resources they use and only for the time that they use it. Now, how many types of clouds are there? There are 3 types of cloud deployments categorized based on an organization's ability to manage and secure assets. First is public cloud. These are managed by third party which provides cloud services over the internet to the public. They offer solutions for minimizing IT infrastructure costs. A public cloud is meant to serve multiple users, not a single customer. Then there are private clouds. These are distributed systems that work on a private infrastructure. These are generally internal to an organization. Then we have hybrid clouds, which combine the facilities of public cloud and private cloud. Based on the type of services that a cloud operator provides, they can be classified into infrastructure as a service or IaaS, software as a service SaaS, or platform as a service PaaS. So as the name suggests, infrastructure as a service, or you can call it IaaS, is cloud computing model where the operator provides virtualized hardware to the users. For example, we can set up our virtual machine on Google Cloud or Amazon Web Services or Microsoft Azure. In software as a service or SaaS, the user can avail some software from the operator on a monthly or annual subscription basis. One very common example of SaaS is Microsoft 365. Platform as a service is where the user can use the operator's development platform to develop and manage the software. So some key players offering PaaS are Bluemix, CloudBees, Salesforce.com, etc. The applications of cloud computing are limitless. So with the right middleware, a cloud computing system could execute all the programs a normal computer could run, and big organization can save millions by moving on to cloud technologies. The offline world has been fast moving onto online technologies. So, another major technology that tries to mimic the real world online is virtual reality. Virtual reality or VR is a computer interface which tries to mimic the real world beyond the flat monitor to give an immersive 3D visual experience. It is an artificial environment that is created with software and presented to the user in such a way that the user suspends belief and accepts it as a real environment. So, VR technology is applied to advanced fields of medicines, engineering, education, design, training, and entertainment. VR also has found great adoption in gaming in the form of VR headsets like Oculus, Microsoft HoloLens, and many more. In this video, we learnt about various future technologies like IoT, cloud computing, and virtual reality. We will meet again in the next video wherein we will talk about some more technologies like AI, 3D printing, blockchains, and many more. Till then, this is Bhavna signing off. Have a great day.